Hello students, welcome back to my channel. This is Nipa Patel from the Math Masters, and today we are going to cover all the remaining questions of exercise 1.2 of chapter 1 relations and functions. Please remember to like the video and subscribe to get the notifications for the new and upcoming videos. Let's get into it.
Question 9. Let function f n to n be defined as f of n equals n plus 1 over 2 if n is odd and f of n equals n over 2 if n is even for all n belongs to natural number set. State whether the function f is bijective and justify your answer. So you are given function from n to n. So if we draw the diagram from domain to codomain, and that is from natural number to natural number. This is our domain, this is our codomain, and the function goes from domain to codomain, and that is f of n. Now since these are natural numbers, it's going to go like this: 1 2 3 4 5 6 7, and keeps on going until positive infinity. Same here, 4 5 6 7 until positive infinity. Now, if we want to see that this 1 gets connected to what number, we need to do what? Use this function. Which function you are given? That f of n equals n plus 1 over 2 if n is odd. So if you see an odd number, you are going to use this function. And if you have an even number, you are going to use this n over 2 equation. And this is for all n that belongs to this natural number. Okay, so if we want to see that where this number 1 goes, so 1 is odd, so here we are going to use this equation. Now if your n is equal to 1, then 1 plus 1 over 2, so this 1 is going to get connected to 1. Now 2 is even, so you are going to use this equation. So 2 over 2 is going to be 1, so 2 is going to get connected to 1. Now as soon as you see that two numbers get connected to one number, that means you can see that this is not 1 function. But let's keep on seeing that what happens. So if 3 is odd, so you are going to use this equation. So 3 plus 1 4 4 over 2 2, so 3 is going to get connected to 2. Now let's see where 4 goes. So 4 even, so we need to use this equation. 4 over 2 going to be 2. Now 5 odd, 5 plus 1 6, 6 over 2, so 5 is going to get connected to 3. 6 is even, so 6 over 2, 6 is going to get connected to 3. So now we can see what happens in this function, that 1 and 2 going to get connected to 1, then 3 and 4 going to get connected to 2, 4 and 5 and 6 going to get connected to 3. Same way 7 and 8 going to get connected to 4. Then 9 and 10 going to get connected to 5. 11 and 12 going to get connected to 6. So looks like every number from the domain is going to get connected to some number in codomain and other way around, because for onto we need to look other way around, that every element in this codomain must have a pre-image. So looks like, yeah, every number will have a pre-image in domain. Why? Because as soon as you go with little bigger numbers, you are going to keep on getting that relation in here, and these numbers are going to go till positive infinity. So here, wherever, whatever number you are going to pick, relative number you'll be able to find in your domain. So that means every element in the codomain that will have a pre-image. So this was just a discussion. Now we need to show that it is not 1 or that is onto as well. Okay, now we are going to start with 1. So this function is 1 or not? Definitely not. See, 1 has two pre-images, so it is definitely not 1. When it is not 1, we cannot prove it. We just need to show the counter example. So we are going to say what? That 1 and 2, they both belong to N. Which N? Our domain N. So 1 and 2, they both belong to this domain. And if you find f of 1 value, since f1 is odd, you are going to use this equation. So 1 plus 1 over 2, and you are going to get 1. If you plug in 2 in there, 2 is even, so you are going to use this equation. So 2 over 2, you are going to get 1. Now from this 2, we can see that f of 1 is equal to f of 2, right? They both are equal. See, f of 1 was 1, f of 2 was 1, but this input are not same. See, here it is 1, here it's 2. So we are going to say f of 1 equals f of 2, but 1 does not equal to 2. So f is not 1, 1. To show that this function is not 1, 1, we just had to give one example. We did that, and we are done with showing that it is not 1, 1. Now we are going to show that this function is onto. Now why am I saying that this function is going to be onto? Because whatever number you pick in here, that number will definitely have a pre-image in this domain. So when every element of codomain is connected to some pre-image in domain, that means that function is onto function, because it doesn't have any spare elements in this codomain, and when that happens, that function is called onto function. Now how do we show that? So look at that, our piecewise function. Since it is piecewise, you are given more than one definition. Here we are given two of them: when it is odd and when that input is even. So we are going to construct two cases. First case is going to be when it's odd. So our case 1 we are doing for now. So when it is odd, we know which equation we are going to use. F of n equals n plus 1 over 2. So now let me draw that diagram one more time. Going from n to n, and this function is f of n, and we are talking about onto right now. So we will be able to find some value y in here such a way that it is connected to some x in here. And if you do, we are talking about odd right now. So if that x is odd, then x plus 1 over 2 if you do, or for now we can use n as well, because we don't want to change our variable. So let's keep it n. Okay. So you can have or pick any element in your codomain. This is your codomain, this is your domain. So pick, let's say you are picking some element y from your codomain, and you are seeing and you are checking that whether it will have a pre-image or not. So let's say it has a pre-image n, and if it has a pre-image n, and if that n is odd, because we are taking this case when that input, that value in the domain is odd, then we are going to follow which function definition? N plus 1 over 2. So when you do n plus 1 over 2, you get y, because that's the function definition you are given. So in this case, I can write what? That this y is equal to what? This output is equal to what when the input is odd? That is going to be n plus 1 over 2. Now when y is n plus 1 over 2, that means you can simplify this. For right now, this equation is solved for y. Just you need to do is solve this equation for n. And to do that, you are going to get 2y is equal to n plus 1, and then n is going to be 2y minus 1. Now think, your y is what? A number in natural number set. That means those all numbers are like what? 1, 2, 3, 4, 5, 6, 7. So any number from those numbers, if you double it and subtract 1, that is still going to be a natural number, right? Why? Because this number itself is a whole number, some 1, 2, 3, 4, 5, 6, 7. When you double it, it's still going to be a natural number. And when you are going to subtract 1, it's still going to be a natural number. So this belongs to n, which n? Our domain n. And since you just proved that when you pick a y, you connect that element, or you can find a pre-image of that element such a way that that also belongs to your domain. That means you have shown that in this odd case, at least this function is onto. And just to show little bit more into detail, you can do what? Function definition f of n when n is odd is n plus 1 over 2. And now just plug in this, because now you have found that n in terms of y. So plug in then in here. So n is equal to 2y minus 1, 2y minus 1, and then write down everything else as it is. Instead of n, we plugged in 2y minus n. And when you do that, you are going to end up getting what? 2y over 2, which is y. And see, we got f of n equals y. And what do we do to prove that function is onto? Exactly this. As soon as you show your, when you input the number in your function machine, and if you get y or f of input or f of x, or in this case f of n, when you get it equal to y, that is nothing but what? That function is onto. So f of n equals y, that means function, or you can say f is onto. So for this case, odd case, we already proved it. Now we are going to do that second case. Second case was what? When it is even. Now when it is even, again let's look at that domain codomain diagram. Let's say this is our domain, let's say this is our codomain, and again it is from natural number to natural number. Function is f of n. Right now we are talking about even, so that function is what? N over 2. Now what I am saying, that you will be able to find an element here, or find any element in here such a way that it comes out from some input n. Of course, right? Let's say that this y is connected to n from this domain. And if this n is connected to this y, that means it is following this function definition, because this function machine is going to convert n into n over 2. So that means y in this case our y is equal to n over 2, because that's what our function says when the number is even. And when y is n over 2, that means your n is going to be 2y. Now think that will you have 2y in your domain? Of course. Why? Because y is in natural numbers. That means y is a natural number. If you double it, of course that number is also a natural number. So that is going to belong to the domain, right? And we can write that this belongs to n, which is our domain. So of course you will be able to find a pre-image whatever element you pick in our codomain. So when your codomain, every element in the codomain has the pre-image, that means that function is onto. So now since f of n in this even case is going to be n over 2, and right now just you found that n is equal to 2y, you are just going to plug in 2y for n, and you are going to try to find the value out of it, and you are going to get what? Y. So see, f of n equals y. As soon as we have this, we can say f is onto in this even case as well, right? So first we showed that function was not 1 1. Why it wasn't 1 1? Because this element 1 was connected to two pre-images. Same way 2 was connected to two pre-images. 3 Same way, every element in codomain, they are connected to more than one pre-image. So definitely that function is not 1, 1. We were supposed to state that whether the function is bijective or not. Now bijective means what? That if a function is both 1, 1 and onto, then that function is bijective. But we just saw that our function is not 1, 1. So of course it's not going to be bijective. And onto, yeah, that function is onto because you will be able to find pre-image for every element in the codomain. So you are going to say what? Hence f is not bijective because it wasn't 1, 1. Question 10. Let a equals all real numbers except 3 and b equals all real numbers except 1. Consider the function f from a to b defined by f of x equals x minus 2 over x minus 3. Is f 1, 1 or onto? Justify your answer. So here you are given a function from a to b such a way that a is all real numbers except 3 and b is all real numbers except 1. And the function definition that you are given is what? F of x equals x minus 2 over x minus 3. And now we need to check whether that function is 1, 1 and onto. So let's start with 1, 1. Now for 1, 1 we do what? We take two elements from domain and then we find the function value for those, right? So let x1 x2 both belongs to A. I don't need to say domain because A is our domain, B is our codomain, right? This is our domain because it goes from A to B. That means A must be domain and B must be codomain. Okay, now x1, x2, let's say they both belongs to our domain set. So that means f of x1, right? Our function definition is this. So if we take f of x1, then it's going to become x1 minus 2 over x1 minus 3. And if we find f of x2, that is going to be x2 minus 2 over x2 minus 3. Now we assume what? That let's say the output of both this input are same. So when you input x1, when you input x2, let's say they both are same. So if they both are same, that means this and this must be same. So x1 minus 2 over x1 minus 3 is equal to x2 minus 2 over x2 minus 3. Now we need to do cross multiplication. So from this to this I am going to multiply, from this to this I am going to multiply, just cross multiplication, right? So if we cross multiply x1 times x2, so I am going to get x1 x2, then x1 times negative 3, so negative 3x1, then negative 2 times x2, so negative 2x2, and then negative 2 times negative 3, so positive 6. And then we are going to do cross multiplication this way. So x1 times x2, so x1 x2, then x1 times negative 2, so negative 2x1, then negative 3 times x2, so negative 3x2, and then negative 3 times negative 2, so positive 6. Since we did cross multiplication, we don't have a denominator anymore. Now whatever is common in both the sides, we can cancel that out. So you can see x1, x2 both sides, I can cancel that out. 6 and 6 can cancel out. So now we are just going to gather all x1 terms one side and all x2 terms on the other side. So if I send this negative 3x1 on this side, I am going to get what? Negative 2x1 plus 3x1. So I will end up getting x1. And when I send this negative 3x2 on the other side, then negative 2x2 plus 3x2. So I am going to end up getting x2. So this is nothing but what? x1 equals x2. And we know that when we start with f of x1 equals f of x2 and we end up getting x1 equals x2 result, that means this function is 1 1 function. So f is 1 1. Okay, now we need to show that this function is onto. So let's start working on that. Now for onto function, we are going to assume some element, or we are going to take some element in our codomain. Because onto is other way around, we need to see that every element in the codomain, they must have some pre-image in the domain. So we go from here to here. So we go from here to here. So that's why we are taking some element from our output set, from our codomain. So let's call it y. So let y belongs to, now this is our B, this is our A, because codomain was B, domain was A. So y belongs to B. Now if y belongs to B, function definition, according to our function definition is what? F of x equals x minus 2 over x minus 3. So this y must have some value x, such a way that x minus 2 over x minus 3 is going to end up being y. So from that function definition, I can say that y is equal to x minus 2 over x minus 3. Now if y is equal to this and I want to solve this equation for x now, right? Because that's what we do. We take one element from our codomain, we use the function definition, and then since we have y equals that equation, we are going to change it to make it x equals that equation. So to do that, I'm going to multiply this x minus 3 over this side. So we are going to get xy minus 3y equals x minus 2. I want to solve this equation for x. That means I have to gather all the terms on one side which has x in it. And whichever term does not have x in it, that's going to go on the other side. So I will have xy. Now I'm bringing x over here. So minus x. Now I'm sending 3y over there. So 3y minus 2. Now this both has x, so I can take x out in the common, and then y minus 1 equals 3y minus 2. Now still I want to solve for x, so I want my equation looking like x equals. So I'm going to do what? I'm going to divide both sides by y minus 1, or I can say I'm sending y minus 1 here in denominator. So 3y minus 2 over y minus 1. So we got our x. Now let's think, is this going to belong to A? A is what? Every real number except 3. And this B was what? Every real number except 1. Now this, any value you plug in for this y, other than 1 of course, because 1 you cannot have for y and you cannot have 3 for x. But you will never have that. See, 1 is not in this B, in this codomain, so you are not allowed to plug in 1. So this is never going to be undefined. And you don't need to do this, but I just want you to understand that why I'm saying that x is never going to be 3. Because when x is 3, this thing is going to happen. 3y minus 2 equals, sorry, 3y minus 2 over y minus 1 equals 3. Why am I making this equal to 3? Because I just want you to show that it is why this 3 is not in the domain, because you will never have a solution for that. See, 3y minus 2 over y minus 1 equals 3 I am making. 3 is not allowed to be, sorry, x is not allowed to be 3, but I just want you to see that why it's not allowed. So you are going to multiply 3 times y minus 1. So 3y minus 2 equals 3y minus 3. Now 3y and 3y is going to cancel out. See, negative 2 equals negative 3. No, not true. So this will never have solution. So this thing can never become 3. So that's why it wasn't there in our domain. See, that's why it cannot be 3. And why it cannot be 1? Because we cannot have denominator undefined, right? So that's why those things are given. You don't need to show this. Just wanted you to understand that. Okay, so any value you plug in from other than those excluded values, you are going to find some value in A for sure. And when your y will always have some pre-image, that means that function is onto. But let's make that f of x equals y that condition as well, since we know our f of x, right? Now, do we know the function definition? Yeah, of course, we are given that x minus 2 over x minus 2 over x minus 3. So f of x equals x minus 2 over x minus 3. Now plug in this x value instead of this x and see what happens. So I'm going to plug in this. So that is 3y minus 2 over y minus 1 minus 2 over, again instead of this x I'm going to plug in this value, which is again 3y minus 2 over y minus 1 minus 3. Now we are going to do what? Multiply negative 2 times y minus 1 in this numerator, and we are going to multiply this negative 3 times y minus 1 in here. So we are going to end up getting 3y minus 2 minus negative 2 times y, negative 2y, negative 2 times negative 1, positive 2, over this denominator is y minus 1 and all over. Now we are going to multiply this. So 3y minus 2 as it is, and negative 3 times y, so negative 3y, negative 3 times negative 1, so positive 3, and all over y minus 1. Now both has same denominator, so this can cancel out because this is going to go in denominator and this is going to go in numerator. So this denominator, that numerator, so anyhow it's going to cancel out in next step. Why not now? Now let's simplify whatever we are left over with. So 3y minus 2y, you will end up getting y, and negative 2 plus 2. So that's going to cancel out, right? Now over in here, see 3y and 3y, this both are going to cancel out. And you got negative 2 plus 3. So you got 1 in here. That means y over 1 equals y. And see, we got f of x equals y, right? We started with f of x and we got y. So when we get this f of x equals y, that is clear-cut case of onto. So f is onto, and I think we were supposed to just do that much only, right? Yeah, is f 1 and onto, justify your answer. This is whole thing is justification. So this was it. F was 1 as well and f is onto as well. Question 11. Let f, real number to real number, be defined as f of x equals x to the 4 power. Choose the correct answer, and you are given these 4 answer choices. So your domain is R and codomain is R. Okay, this is our domain. This is our codomain. This is our function f of x, and definition is x to the 4 power. Now since all real numbers, I'm just going to try to write as many as I can. So negative 3, negative 2, negative 1, 0, 1, 1.5, it's everything is there, right? 2, 3, all real numbers that you can think of. Same way here, negative 3, negative 2, 0. Let me add some decimal as well, so we can see that this is real number set. So 0, then 0.5 in here. So here I'm going to add 0, then let's say 0.625, then let's say 1, 2, 3, 16, 17, 18, and keeps on going. Every real number, every rational, irrational, whatever number you can think of, it's there in domain, it's there in codomain. Now the function definition is what? Fourth power, right? It is the 4 power of that element in the domain. So Okay, I don't have that negative 3, but I'm going to try to connect from negative 2. So negative 2 is going to get connected to 16. Why? Because negative 2 to the power of 4 is going to become what? 16. 2 to the power of 4. It's going to be also 16. Why? Because it is even power. So every time you do even negative number or positive number power, it's always going to be positive. Why? Because of that even power. Negative 5 is going to get connected to 0.625, 0 is going to get connected to 0. But as soon as we saw this, that negative 2 got connected to 16 and 2 got connected to 16, that means 16 has two pre-images. That means we can say that it is not 1, 1. Definitely not 1, 1. And can you think of any number whose power of 4 is going to be negative 2 or negative 3? What did I just say? When you have a even power, you will never have your answer as negative number. Why? Because then you are multiplying that even power 4 times, right? If it is, let's say, negative 5 to the 4 power, that means you are multiplying negative 5 times negative 5, going to be positive, then again times negative 5, negative, and then again negative 5 you are multiplying, so it's going to end up being a positive number. So these numbers which are negative, they are not connected to any pre-image in this domain, so it is not onto either. Okay, so this function is not 1, 1, this function is not onto. Let's say if we had to write systematically, so we are going to show what. Okay, let me first write this. Function is from R to R. So domain is all real number, codomain is all real number, and then function definition you are given is x to the power of 4. Now for 1, 1, since we know that this function is not 1, 1, we are just going to show the counter example. So we are going to say what? Yeah, this negative 2 and 2 got connected to the same number. Same basic, negative 1 is going to get connected to 1 and 1 is going to get connected to 1. So whatever you want to pick, you can. So negative 1 comma 1, they both are in the domain R. This R is our domain. They are both in this domain, and f of negative 1 is going to be negative 1 to the power of 4. It's going to be positive 1. F of 1 is going to be 1 to the power of 4. That is also going to be 1. And both are same. See, f of negative 1 is equal to f of 1. But this input are different. See, negative 1 does not equal to 1. So, f is not 1, 1. Now we are going to show onto. For onto, we know that it's not onto. So again, let's take the counter example. So negative 2. So we are going to say that negative 2 belongs to R. In this case, we are talking about codomain, because for onto, we need to take an element from codomain. So negative 2 belongs to R, but negative 2 has no pre-image in domain R. So F is not onto. Now we got this function as not 1, 1, not onto. Let's look at those multiple choices. Is 1, 1 onto, is 1, 1 but not onto, is many to 1. Okay, so then it should be D, because F is neither 1, 1 nor onto. So our correct answer is D. Question 12. Let f R to R be defined as f of x equals 3x. Choose the correct answer. So you are given a function from real number to real number. So domain is real number, codomain is also real number. And function definition you are given is f of x is equal to 3x. So now let's start with checking onto. So let x1 and x2 both belong to R, which are domain. And since we know f of x equals 3x, then f of x1 is going to be 3x1 and f of x2 is going to be 3x2. Now let's assume that f of x1 is equal to f of x2, and that's going to happen when 3x1 is equal to 3x2, and that's only going to happen when your x1 and x2 they both are same. So f is 1 1. Now we are going to check onto. So for onto you are going to take an element in your codomain, and since we are picking an element from codomain, let's call it y, because that is our output. So we always take our output as kind of y, right? So y belongs to R, in this case our codomain. So that function definition was 3x. So then y must be equal to 3x. That means x must be equal to y over 3. And do you think that y over 3, any real number, if any real number you divide by 3, do you get a real number? Of course you do. If you divide any real number by 3, that result is of course going to be a real number. So this is going to, of course, it's going to belong to R. So yeah, looks like that any output you pick from your codomain, you'll be able to connect it to some domain, some element in the domain. So for that, you can show a little bit more that now f of x equals what? What was our function definition? 3x. And in this x, you can plug in this x value. This x value we got as y over 3, and then 3 and 3 is going to cancel out. So this is going to become y. So as soon as we see, so f of x is equal to y. So f is onto. So this function is 1 1 as well. This function is onto as well. Let's see what kind of multiple choices we are given. Not many to 1, neither no, but not on. Okay, so then it should be A. Our answer is A.
Okay, so that's it for this video. Please remember to like and subscribe. See you all in the next video. Thank you.